So I'm expecting this to be a short video and somewhat transitional. The laser cutter works, and I anticipate those videos to, in a sense, wind down. But I've got some overhead transparency sheets, the circuit board, CAD file, and a laser cutter. So what we're going to try to do is we're going to try to make solder paste stencils. I'm not sure how it's going to work. I know people have done it. I know I'm certainly not reinventing the wheel. But I'm going to try it out, and if it works, that'll be really great. So the project that it's going to be used for is we're going to do another low noise amplifier. If you read my blog, you'll know that I've done a low noise amplifier relatively recently. This is going to be a similar model. It's Skyworks as well, but it's the same footprint. Skyworks has the same footprint for 3 different frequencies or 3 different bands, I should say, of low noise amplifiers. So we're going to be transitioning to this project after the laser cutters are done. So we're going to try to cut out some laser cutter stencils to do solder mask and reflow soldering of this board, and then we're going to do some RF work. Moving forward, I do really enjoy working with electronics and radio frequency, so I anticipate more of those videos coming. Anyways, yeah, so let's go ahead and get started. I think the best way to handle this is to start with the CAD file and turn off all of the layers other than top cream, which I'm pretty sure means solder paste. Okay, so apply that. Alright, oh, I have to turn off the silk screen. Okay, so there we go. So that should be the solder mask. There's one thing I need to do, which is not have the hash pattern. So let's see. Fill style, let's turn that to be solid. And we can leave the color, let's make the color red. Okay. Okay, that'll do just fine. So now we've got all of these lines, and I can print this to a PDF. I want to make sure that it's actual scale. I know you can't see these dialogues, it's too bright. Okay, so we're going to do scale factor 1. The rotate or mirror I don't think matters. You can see in the corner that's how big it would be. We're going to print a file, and I'm going to print it to the desktop and call it mask or stencil. Okay, we'll call it stencil. Save it. Okay. Alright. So now our stencil file should be in here. There it is. So load up Inkscape. We'll import the stencil. Okay, so there's that. Okay, and then we'll go ahead and open it in VisiCut. Okay, so that looks like it worked just fine. That's probably worth a shot. Okay, so I'm going to get the laser cutter booted up, and I'm just going to go for it. I think that's just the line width that VisiCut uses. So we'll see if this works. Alright, so we're ready for the first test. I'm leaving it pretty normal. I'm going to do 100% speed. I don't have PWM yet, so that's an upgrade that might come later. It's also using 6 milliamps. I've got a piece of wood under there to get the focus in the right point. I'm going to be cutting in that big open area there, so there won't be anything below it. Let's try it out. So in some sense that was successful, but it was also way too much power. So I'm going to lower it way, way, way down and try it again. Alright, I'm going to do exactly the same thing over again. I moved that first one over, and I also set it to just under 3 milliamps. The laser still fires, but it should have considerably less power now. Well, it's better, but I think we can do even better still. Let's try... I'm going to set it down as low as it still fires. Alright, I've got the laser powered down as kind of as far as it will go. So now it's to the point where the SMA connectors don't really pop out. So the pads on the QFN still aren't defined, and I think it's this center job here. So what I'm going to do is remove this whole pad, and I'm going to replace this with just 4 lines, so it doesn't actually try to cut a hole. And I think that the diameter of the focus spot will be enough to open those holes up for the right amount of solder paste. So I deleted the old footprint from the QFN and I replaced it with these just single lines. I don't think the width matters because I think that it'll just draw a single line across there. So we're going to load this up into VisiCut. Alright, cut everything. Let's zoom on in so we can see the 4 different lines on each of those layers. Let's move it back to where we want it. Okay, so it's back over there. I've still got that ludicrously low power setting. And let's try it out. Way cool. Alright, so as a recap, there's the first attempt. That's at 6 milliamps and 100% speed. That is 3 milliamps at 100% speed. That is as low as it would go at 100% speed. And these guys here, they didn't cut through. but that doesn't bother me. I wouldn't actually want those pasted anyway because I soldered them on later. This one has that new footprint for the QFN, and that's actually really useful. My only remaining concern is that it's still got a bit of texture. It's thicker on there than next to the edges than just the bulk material is. And I don't know if it's a good idea or a bad idea to sand it. I'm tempted to, but I think that I should also look into what material people use. This is a laser printer overhead slide, so it's pretty generic. So I think I'm just going to slightly sand it to take down the rough edges. So I went ahead and sanded the stencil to try to get some of those raised edges knocked down. It worked, but it left obviously a rough surface, and I'd have to work to get all the debris sort of out of the holes there. Okay, so I did some research on the internet about cutting these solder stencils. I had intentionally not done any before I started, just to see if it's the kind of thing that I could understand what I'm doing, sort of without help, to see if I understand how things work and can sort of do this laser cutter stuff on my own, as it were. So, I think that I could have gotten somewhere with the work I did, but there's a few tips that I caught. And so one is to go in Eagle, you can do the design rule checks, and by setting in the masks, I knew about the I think it's called restring. I don't remember for sure, but I know that you can add an extra gap around the pads, outside of the pads in the solder mask. And I didn't realize that you can also add a gap from the edge of the pad inside to where the solder mask is. So I can say 2 mils, 2/1000ths of an inch, is the minimum distance from the edge, and then 20% shrink, and then up to 10 mils. And then if I apply that, we can see that the all of the pads have a smaller solder mask on them. So that should help in sort of the over-etching that I was getting before. Another thing to do is to engrave rather than cut. And that should also help with the over-engraving by reducing the time that the laser spends in any one spot. So I'm going to convert this new graphic, just like I did the first one, and bring it into Inkscape and load it up, and then I'm going to cut this one out, and we can compare and see how well it's working. Alright, so in VisiCut, I've did a couple of things. First, I decided to have a name for the stencil put in and have it engraved along with everything else, and that should help me know what these stencils go to later. I deleted the parts for the SMA connector because I actually didn't even want them there. This is the... Oh man, the Moria is just killing my phone. Okay. So this is the outline for that QFN, and this is just the Eagle produced output. I haven't messed with this one at all. And so I'm hoping that I can just leave it as is and not have to manually fix it. So I have also an outline that I'm going to have it cut out. So I've got the engrave and the cut set up. I'm going to use 100% speed for engrave, and I'm going to use 80% speed for cut. And I'm going to use the the low power setting where the laser just barely fires. So I'm going to get the laser cutter turned on, and then we'll try this one out. So I kind of cheated on that one. I was basically turning the power up slowly as it was engraving. So I'm going to do it again and keep turning the power up just a little bit at a time. Well, I just cut an entire stack of tests. So let's see. I started by, I don't even know where the first one is. Basically, my process was to do etching, and I started at the lowest power level, and it wasn't etching all the way through, and so I turned the power knob up and up until it started to kind of cut, and then that job was finished by the time I did that. And then I did another one where it kept going up, and then eventually I got I did 5 milliamps, and then the 5 milliamps still didn't go all the way through at 100% speed, and then I did 6 milliamps, and it still didn't, the top's pretty well etched, but it didn't go all the way through on 6 milliamps engraving. And then I started reducing the speed. So these are really hard to see. So this is 6 milliamps at 50% speed. And some spots are starting to cut through, but not really. And then I did, no, there's one I didn't label. Okay. I think the one I didn't label, I think this one is 6 milliamps at 25%. And all of the pads for the 0603s are cut through, but the QFN, it's starting to get to the point where they all sort of munge together. So I wasn't, I didn't think that one would work. So I tried to do a mix. I tried engraving and cutting. And on this one, I did cutting after I cut the outline, so it sort of fell and got out of focus and off alignment. But I could tell it wouldn't work anyway. Okay, my camera ran out of space there, so I had to stop and delete some stuff. So this one is 6 milliamps. The lines on the QFN are still a cut rather than an engrave, but this one's different from the last cut, 6 milliamps, in that I rotated it this way in the laser path. So my thought was that the long way of the QFN leads would be going with the fast dimension on the laser versus this one. Remember, this one also fell down when it got cut, and so that's part of why it got screwed up. Okay, so the last one, and the one I'm really excited about, is 6 milliamps, 25% engraved speed, and engraved everything. And I just left it normal on the engrave. I didn't use the lines like I did on that one. I used the original outlines from Eagle. The difference on this one is that I cut it this way, so the long dimension of the QFN pads were along the dimension, the scanning, the fast scanning of the engrave, but also I increased the resolution that VisiCut uses to compute the lines to be 1,000 DPI, maybe? I'm not sure what the 1,000 is, but it's normally 500. So I increased it to 1,000. And this one, I think, is actually usable. It's hard to see on the camera, but those are definitely clearly open holes. They look to be pretty close to the right size, but this is definitely going to be enough to try. So that'll be the next thing I do. All right, well, that's it for cutting SMD stencils with the Chinese laser cutter. Thanks for watching. As always, I'll see you next time.